right, guys. Finally, we are down to day 7 notes, and this is where we will talk about what the molecular formula is and how that relates to the empirical formula and how we can figure that out. Okay, so like I said in the last video, a molecular formula, okay, is the actual, so let's just make a note of this. The molecular formula, I don't know where to make my note. The molecular formula is the actual formula of one compound. Okay, so it tells you exactly how many atoms of each element there are in that compound. The empirical formula, we said, is the simplest whole number ratio. Okay, and the way that it works is the empirical formula, we could have an empirical formula that's the same for a bunch of different molecular formulas. Okay, for example, CH2 is an empirical formula. You could make a dozen, and actually in nature there are many dozens of compounds with this empirical formula. The molecular formula could be C2H4, C3H6, C4H8, C5H10. Okay, you get the idea. Any of these compounds, so this is a compound called ethene. This is a compound called propane, and these are compounds that actually exist. They have the same empirical formula. Okay, and the reason that this is necessary is because of testing in the lab to identify compounds. Okay, so to determine the molecular formula, okay, from an empirical formula, the first thing you do is if you're given a percent composition, you would have to first determine the empirical formula. If it's not given to you. In some problems, I'll just give you the empirical formula. Okay. Number 2, we're going to use that formula as follows. Okay. What we're going to do here is to figure out the molecular formula. You take the molar mass of the molecular formula. So I would have to give you that. And that's a good way to identify the type of problem. Is in calculating molecular formula, I would have to give you the molar mass of the molecular formula. Okay, so we would take the molar mass of the molecular formula and we would divide it by the molar mass of the empirical formula. Okay, and what we should get are some whole numbers. A whole number. And what you're going to do is you are going to multiply the subscripts in the empirical formula by this whole number that you figured out in step 2. And that's going to give you the molecular formula. Okay, so let's do an example. All right, so what is the molecular formula for a compound that has 74% carbon, 8.7% hydrogen, and 17.3% nitrogen, and has a molar mass of 243.39, okay, grams. So the first thing we've got to do is we've got to calculate the empirical formula. So you remember the first thing you do there is you convert the percent to grams. So this tells us I have 74 grams of carbon. I have 8.7 grams of hydrogen. I have 17.3 grams of nitrogen. Okay, so percent to mass. Remember, the next thing is to convert the mass to moles. So I need to find the molar mass of the elements on the periodic table. So the molar mass of carbon is 12.01 grams in 1 mole. All right. Hydrogen, we're going to convert hydrogen to moles. So the mass goes on the bottom. 1.01 is the molar mass of hydrogen. And that's 1 mole. And then nitrogen, the molar mass of nitrogen from the periodic table is 14.01 grams. That's equal to 1 mole. Okay, now we're going to do these calculations. All right, calculator. Let me slide this up a little bit so you can see what we've got. All right. So 74 divided by 12.01 is 6.1615. Remember, I'm going to carry these numbers out just because it makes that division step more accurate. Okay, 8.7 divided by 1.01, 8.61. I'm going to go with 8.6139. These are moles. And then nitrogen, 17.3 divided by 14.01, 1.2348. Okay, percent to mass, mass to mole. Now we're going to divide by the smallest. So this 1.2348 is the smallest, so I'm going to divide everything by that. All right, so this is going to equal 1. 8.6139 divided by 8.6139 divided by 1.2348, 6.98, what I'm going to go with, which is close enough to 7, okay? And then 6.1615 divided by 1.2348, 4.99, which I can round to 5. Okay, so since these are all really close to whole numbers, okay, that tells me my empirical formula is, let's see, C5H7N1. C5H7N. So this is my empirical formula. Okay. So that we've done before. Now, to figure out the molecular formula, we have to do 2 things. First thing we have to do is we have to calculate the molar mass of our empirical formula. Okay, so 5 carbon is 12.01. 7 hydrogen is 1.01. 1 nitrogen Nitrogen is 14.01. We're going to add these all up. So I've got 14.01, 7.07, and 5 times 12.01, 60.05. So I'm going to add those all together. All right, so we have a mass of 81.13 grams. That's the mass of our empirical formula. Now, the problem tells me that the compound has a molar mass of 243.39. So what I'm going to do is I'm going to take the molar mass of, I'm going to abbreviate here, molecular formula over the molar mass of empirical formula. Okay, so 243.39 divided by 81.13. What do we get? 243.39 divided by 81.13 is 3. Perfect. So now what do we do with that 3? We take the empirical formula and we multiply all of the subscripts by 3. So we end up with C15, H21, N3. And this is our molecular formula. Okay. And again, the one thing that I ask you to do with this is always put a box around your answers so that I know what your final answer is. Okay, so that is an example of how to calculate an empirical and molecular formula. Okay, I'm not going to do another one of these. Hopefully we'll be in class and we can work on these and you will catch on. It's just memorizing the steps to go through and understanding what you're converting to and from. But it shouldn't be too bad. And that is a wrap on this first unit of 2024.